Given that segment BP is the perpendicular bisector of segment AC and CP is the perpendicular bisector of segment BD, and finally that PS is congruent to PR, which of the following statements is not necessarily true? Is it A, that triangle ABC and triangle BCD are isosceles? Is it B, that AB is equal to CD? Is it C, that BP is an angle bisector of angle ABC? Or is it D, all of the statements are true? Well, let's investigate our diagram with the information that we are provided. So first, we know that BP is the perpendicular bisector of AC. So here's segment AC. It's already marked that it's perpendicular. I'll mark it on the other side. And then it also bisects segment AC into two congruent pieces. We would also be able to prove, if I look at triangle ABR and triangle CBR, we would have a reflexive property with BR being congruent to itself. So then these two triangles, the smaller ones, triangle ABR and triangle CBR, would be congruent by side angle side. And by the corresponding parts of congruent triangles are congruent, we can say that segment AB is congruent to segment BC. We can also prove that this is true using the constructions of a perpendicular bisector. When you construct a perpendicular bisector, the vertices of the endpoints are equidistant from the perpendicular bisector. And I'm going to show this with circles. I'm going to do green ones so you can see. If I was to construct a circle from A to B, and then from C to B, we can see that this perpendicular bisector falls in it, and segment AB and segment BC are radii of circles that have congruent lengths. So that's the other reason why AB is congruent to BC. Okay, now let's look at the next one. So we just proved that this one is true. AB is equal to CD. Well, if we also use that either congruent triangles with side angle side again with triangle BCS and triangle DCS, we would be able to prove that segment BC is congruent to segment CD. Similarly, because CP is the perpendicular bisector of BD, and again we can show this with the circles that we have from B to C. Let me do that again. From B to C, I make the circle there, and then from D to C, make the circle there too. We can see the perpendicular bisector, and because these radii are congruent, we can say that BC is congruent to CD, and therefore their measurements are equal. And then if AB is equal to BC and BC is equal to CD, I can say that AB is equal to CD by the transitive property, so therefore choice B is also true. Now let's look at the third one. BP is the angle bisector of angle ABC. Well, when we first started talking about AB being congruent to BC, we had proven that triangle ABR was congruent to triangle CBR, and similarly, by corresponding parts of congruent triangles being congruent, we can say that angle ABR is congruent to angle CBR. So therefore, BP is the angle bisector of angle ABC. So this is also true. Therefore, our answer choice, or the final answer, is D, all of the above.